Hello everyone, this is Dr. Anand. Today, I will be taking you through the Knime platform to perform the correlation analysis. I have already launched a new project, project number 19. If you want to launch a new project on the Knime platform, please go to File, click New, select a wizard, Windows would open. You have to click New Knime Workflow and automatically a new project will launch. So once after you launch the project, you can also give a name for your project. So now the very first node which we want is the file reader. So go to your node repository and type file reader. When you type file reader, you'll get different types of file reader nodes here. I think you can see file reader, table reader, DB reader, but I'm going to use this file reader complex format. I'll tell you the reason why I am going to use the file reader complex format. Before that, let me first import the data. I'm going to use the GDP data. So the name of this node is going to be GDP data. I'm right clicking. I'm clicking configure to import my data. I'm going to browse option. I have to locate the folder where I have saved my data. And I'm going to import my GDP data. The data has been imported. I'm clicking apply. I'm clicking OK. You can see that there is a change in the signal color from red to yellow, which means the node is ready to be executed. I'm right clicking, I'm clicking execute. The node has been executed. Now let us check the data output, right click and view the file table. So when you see the file table, you can see that there are 23 rows and 15 columns, which means the data pertaining to GDP has been collected from the year 2000 till 2022. And you also have different types of column elements. For example, target, GDP, agriculture, export, import, cereal production, crop production, cereal yield, food production, livestock, land area used for cereal production, subsidies given by the government, wheat, crude oil, and beef. So it is a small observation that this data file has 23 rows and 15 column elements. So now very successfully, we have imported the data. However, it is very important to check if there are any missing values. So it is always good to use the statistics node. So go to your node repository and type statistics. So when you type statistics, you can see the statistics node. Please import the statistics node into your workstation. Now connect your GDP data file to your statistics node. So once after you connect it, you can also give a name. Apparently, we are going to check whether any missing values are there. So I'm going to give a name, checking missing values. So now let's import it. The data has been imported from the file reader. Now let us configure, right click and press configure. So you can take all the data into the inclusion box, click apply, click OK, and it is ready to be executed. You can execute it. So now there is a change in the signal color from yellow to green, which means the data file has been executed. It is ready to be viewed. Right click, when you do a right click, you can see three outputs, that is statistics table, nominal histogram table, and occurrence table. You can check the statistics table and you can also see the number of missing values. Apparently, there are no missing values, which means the data is perfect and you can proceed with the analysis. Now, before proceeding with the correlation analysis, let me explain about the example which I have taken. For example, if the government of India wants to propose new economic reforms in the year 2023, in that regard, The government of India has considered three important areas which can contribute very successfully to the Indian GDP. The first area is crude oil, the second one is livestock, and the third one is cereal production. So you have been appointed by the government of India as a data scientist. It is your duty now to collect the data, to perform the analysis, and propose a solution to the government of India, which area is best and which will contribute towards the GDP growth. So now let me open my Word document and let us do some small writing work. So I've told you before, we are going to perform a correlation analysis. So the government of India wants to enhance the GDP position, and hence it has selected three important areas. So what are the three important areas? The first one is crude oil. The second one is livestock. And the third one is cereal production. So in this regard, we also have to know which is the independent variable and which is the dependent variable, right? So there are two different types of variables here. So GDP will become variable X and remaining three will become variable Y. It is always good to frame the hypothesis before beginning with the correlation. So hypothesis has been classified into alternative hypothesis and null. Alternative hypothesis and null hypothesis. Okay, now what do you mean by null hypothesis? Null hypothesis means there is no significant relationship between two variables. No significant relationship between two variables. And what do you mean by alternative hypothesis? Alternative hypothesis means there is a strong and significant relationship between two variables, right? Okay. So now the hypothesis has to be framed for all the three variables here, that is crude oil, livestock, and cereal production. So hypothesis for crude oil. Then we'll be framing hypothesis for livestock. Then again we'll be framing hypothesis for cereal production. So there are three different hypotheses which we have to frame. So basically hypothesis is classified into alternative hypothesis and null hypothesis. Null means there is no relationship between the variables, and alternative means there is a very strong and significant relationship between the variables. Now let us frame the null hypothesis and alternative hypothesis for all the three variables here. So I hope you are observing whatever I'm doing. Okay. So let me just differentiate the colors so that it becomes very easy for us to know. So the very first hypothesis, that is a null hypothesis for crude oil, there is no significant relationship between GDP and crude oil, right? Alternative is there is a very strong and significant relationship between GDP and crude oil. So the very first hypothesis has been framed very successfully. Second one is for livestock. So there is no significant relationship between GDP and livestock. The alternative hypothesis will be there is a strong and significant relationship between GDP and livestock. Okay, the last hypothesis is for the cereal production. So what is the null hypothesis? There is no significant relationship between GDP and cereal production. Okay, and what is the alternative hypothesis? There is a very strong and significant relationship between GDP and cereal production. So there are three different hypotheses which we have framed. So correlation analysis, we have to take X variables and Y variables. X variable is GDP and Y is crude oil, livestock and cereal production, which we will be exploring separately. Now, we also have to frame the hypothesis. Either hypothesis will be accepted or it will be rejected. And there is also one more important aspect which we have to understand. In correlation, the p-value plays a very important role. What is the p-value here? Which is nothing but the probability value. The probability value. So now, this probability value itself has to be understood in a different dimension. The first one, if the p-value is less than the significance level, What is the significance level? P is equal to 0.05. That is a threshold limit. So if the p-value which we get is less than the significance level, then what is the decision? The decision is to reject the null hypothesis. If we reject the null hypothesis, it means that we are accepting the alternative hypothesis. Accepting the alternative hypothesis. Okay. Now, what will happen if the p-value is not less than the level of significance? If the p-value is not less than the level of significance, in that case, what will be the decision? Accept the null hypothesis. In that case, what will we do? We will reject the alternative hypothesis, right? So in correlation, we have to take into consideration the probability value. The level of significance, a rule of thumb is 0.05. So if the p-value is less than the 0.05, what should be the decision? We have to reject the null hypothesis and we have to accept the alternative hypothesis. In case if the p-value is not less than the level of significance, then what should be the decision? We have to accept the null hypothesis and we have to reject the alternative hypothesis. Now, what should we find? I've told you before, the government of India wants to find 3 good and unique areas which is contributing towards the economical growth of the nation. So the economical growth of the nation can be measured using GDP, gross domestic product. However, there are 3 different areas. One is crude oil, other one is livestock, and the third one is cereal production. So as a data scientist, you have been given this task to find which area is contributing more towards the GDP development, right? Either is it crude oil or either is it livestock or either is it cereal production. So this is what we have to perform in the Knime platform. Now let me go back to the Knime platform. First, I explained about importing the data. Then statistics node has been used to check if any missing value is there. Now, the next node which we need is a column filter. Why do we need a column filter? Very simple. First, we have to find the relationship between GDP and crude oil. Then we have to find the relationship between GDP and livestock. Then we have to find the relationship between GDP and cereal production. So that is why we have to take only those elements which are needed. So now, logically thinking, how many column filter nodes I need? I need 3. Why do I need 3? One for crude oil, one for livestock, and the last one is for cereal production, right? So please arrange your column filter node inside your workstation. You can also give a very good name. So the first one, first name, X is equal to GDP slash Y is equal to crude oil. So in correlation, we need two variables. One is variable X and the other one is variable Y. So variable X is going to be GDP and variable Y is going to be crude oil. Second node again, X is equal to GDP and Y is equal to livestock. The third one, again, X is equal to GDP and Y is equal to cereal production. Oh. So now, please connect your GDP data to your column filter. So I'm connecting my file reader to all the column filters. As soon as I connect, you can see there is a change in the signal color. It has moved from red to yellow. Now let us configure this. Right click, configure, remove everything and take only the target variable, that is GDP and crude oil. Click apply, click OK and execute it. Now please check the output. If you check the output, you have only GDP and only crude oil. So the second row, the column filter we have to configure, right click configure, remove everything into the exclusion box, take only GDP and take only livestock. Click apply, click OK, execute it. Check the data. You can see only GDP and livestock. For the third one, again, right click, configure, keep everything inside your exclusion box, take only GDP and take only cereal production. Click apply, click OK, and please execute it. So check the output. So you can see that we have only GDP and we have only cereal production. So now we have taken only those data which we want using the column filter node. Now, let us use a linear correlation. So go to your node repository and type linear correlation. You get to see this node, which is represented by green color and red color. So please take that into your workstation. So we need 3 different nodes here because we are going to perform 3 different correlations. If you want, you can give the same name for this correlation node also, but I'm just going to give a simple name, correlation 1, then correlation 2, then correlation 3. Okay, now please connect your column filter node to your linear correlation node. So after it has been linked, let's configure it. Right click, configure. So you can see that we have only GDP and crude oil. Click apply, click OK, and execute it. Execute for the second and execute for the third. Now let us check the output. Check the correlation measure. So correlation measure, you see the first column, second column, correlation value, p value, and degree of freedom. So now let us copy this to write the inference. So let me open my Word file. Yeah. So what is the first correlation here? The correlation between GDP and crude oil. And this is the output which we got. So let us write inference. So from the correlation analysis, it has been observed that the p-value obtained, which has been obtained, is p is equal to 2.30, right? Which is more than the level of significance. What is the level of significance? P is equal to 0.05. So what will happen if the p-value is more than the level of significance? Can you see this? If the p-value is less than the level of significance, we reject the null. In case if the p-value is not less than the level of significance, then we accept the null hypothesis. In this case, our p-value which we have obtained is 2.30, right? So that 2.30 is not less than the level of significance, that is p is equal to 0.05. So what is the decision? We accept the null hypothesis. So in this regard, we accept the null hypothesis. So can you tell me what is the null hypothesis? There is no significant relationship between GDP and crude oil price. So you can write that in the brackets. So this is the inference for the first correlation which we have done. Now, let us check the output for the second correlation, that is the correlation between GDP and livestock. Right click and check the output, that is correlation measure. Again, if you see, the p-value is 2.26, same. So how do we write the inference? The same inference you can write, provided only the names and values you can change. Let me also take a screenshot of that output so that it will be very easy for us to write the inference. So I hope this is easy to follow, right? So from the correlation analysis, it has been observed that the p-value which has been obtained, what is the value which we have obtained? That is again 2. Sorry, it's not 2.30. Let us check the output again. Yeah, it is 2.2655. 2.265, which can be assumed as 2.26 only, or 2.27. Yeah. So the obtained p-value is 2.27, which is more than the level of significance, that is 0.05. In this regard, we accept the null hypothesis. What is the null hypothesis? There is no significant relationship between GDP and livestock. Right? So this is the inference for the second correlation. Now, we still have one more. What is that? The relationship between GDP and cereal production. So let us go to our Knime platform. Let us check the output. Go to the correlation measure. Yeah, you can see that this is just 0.17. No, somewhere it is different. So copy this, paste it here, and again write the inference. Again, 0.17 is more than the p-value only. So from the correlation analysis, it has been observed that p-value which has been obtained is 0.17, which is again more than the level of significance. In this regard, we accept the null hypothesis. What is the null hypothesis? There is no significant relationship between GDP and cereal production. Okay. For all the three correlations which we have done, there is no significant relationship between GDP and crude oil, GDP and livestock, GDP and cereal production. But strictly speaking, if you do a small comparison between all the three, which one has a very positive area, where the government can invest and where the government can concentrate, you have to compare all the three, which is equally very important. In this example, which I told you, if you logically compare all the three, that is the relationship between GDP and crude oil, GDP and livestock, and GDP and cereal production, the very promising field is GDP and cereal production, taking into consideration the p-value. So again, I'm going to reiterate on the p-value. If the p-value is less than the level of significance, then the decision should be to reject the null hypothesis and to accept the alternative hypothesis. In this case, if you see, we have got three different p-values. So now let us take only the p-values and let us compare only the p-values and then come to a conclusion. So let us insert a small table here. So first one is crude oil. The second one is livestock. The third one is cereal production. So what is the p-value obtained? What is the p-value which we have obtained for crude oil? 2.30. 2.30. What is the p-value which we have obtained for livestock? 2.26. 2.26. And what is the p-value which we have obtained for cereal production? 0.17. Okay. Now, this 2.30 is more than 0.05. This 2.26 is also more than 0.05. I'll put it in this way. 2.30 is more than 2.26. 26 is more than 0.0. Again, 0.17 is more than 0.05. So this is status or outcome. These are the variables. Okay. Now, the last column is going to be hypothesis. Okay. Now, I've told you about the hypothesis, right? If the p-value is less than the level of significance, then we reject the null hypothesis. If the p-value is less. But if you see, if the p-value is not less than the level of significance, then what is the decision? Do not reject the null hypothesis, right? Which means you have to accept the null hypothesis. So we accept the null hypothesis. For this one also, accept the null hypothesis. For the last one also, you have to accept the null hypothesis. So there is no significant relationship between GDP and crude oil, no significant relationship between livestock and crude oil, no significant relationship between cereal production and crude oil. But when you compare all the three, the cereal production is somewhat better than the other two, that is crude oil and livestock. Because if you check the p-value, it is somewhere close to 0.05. In case if it is less than 0.05, if the obtained p-value is less than 0.05, then we would have rejected the null hypothesis and we would have stated that there is a significant relationship between cereal production and crude oil. So in this case, we can write an inference stating that cereal production is very important for the Indian economy. There is always a very good demand for consumption, and cereal production is always used in the Indian meals, right? So people will keep on buying the cereals, and these days everyone have become more organic, right? We all give a lot of importance to health. So more than all the other production, cereal production might enhance the GDP position of the nation. This is how we have to conclude. So I'll give you a small summary what we have done. I've given you the meaning of correlation analysis. I've taught you how to frame the hypothesis, the two varieties of hypothesis, that is null and alternative. We also use the Knime platform to perform the correlation analysis. We took the file menu. We took statistics to check the missing value. We also used different column filter to take only those elements which are needed for correlation analysis. We have also performed the linear correlation for GDP and crude oil, GDP and livestock, GDP and cereal production. We have also returned the inference for all the three. We have also come out with a comparative table to find which one is better for the Indian economy. So I hope this video was useful for you to understand how to perform correlation analysis using the Knime platform. Let me meet you with another video.